Assalamualaikum. So today we are from group 1 table 1 and we get first configuration for this lab assignment. This is our circuit, which is passband filter, and we are using the maximally flat and third order of the passband filter. So the impedance is 50 ohm, the frequency center is 868.40 MHz and frequency maximum is 873.664 MHz and F min is 862.408 MHz. All of the frequency we get from the lab 1B. For the delta, the formula is F max minus F min over center frequency and time 100%. So the F max minus the F min and divide the F center and we get the 1.290%, and then we convert, become 0.0129. For omega, we use 2 pi f, which is F is the center frequency, and then we got 5.456 gigahertz. And then we start calculate our component, which is L1, C1, L2, C2, L3 and C3. For L1, we use the formula G1 times by Z0 and over omega times by delta. For G1, based on the maximally flat table, the value is 1 and the Z0 is 50 ohm. Over omega is 5.46 giga times by 0.0129 delta. So for L1, the value is 709.884 nanohenry, and for capacitor, the formula is delta over Z0 times by omega times by group 1. The delta is 0.0129 and over Z0 is 50 ohm, omega is 5.46 giga and the group 1 is 1. So the total for C1 is 0.0473 picofarad. Next, for L2, we are using the same formula, which is delta times by Z0 over omega times by G2. The delta is 0.0129 times by 50 ohm over 5.46 giga times by G2 is 2. And the answer for L2 is 0.0590 nanohenry. And the C2 is G2 over omega times by delta times by Z0. The G2 is 2, the omega is 5.46 giga times by 0.0129 and times by 50 ohm. So the total of C2 is 0.5679 nanofarad. For the value of L3 and C3 is same as L1 and C1. So that's all.
Okay, after we create the circuit, we transfer the circuit into ADS, Advanced Design System. We create exactly in the schematic. We use 3 inductor and 3 capacitor. We use them as our source. For value for inductor is 709.884 nanohenry, same as the value we calculate. The capacitor one is 0.04725 picofarad. Then for L2 is 0.059 nanohenry. For capacitor number 2 is 0.5679 nanofarad. And for L3, we use at the same one as L1, C3 as same as C1. Then we use S parameters. For S parameter, we use start equal to 850 MHz, stop equal to 900 MHz, and step equal to 500 kHz.
So after finish the schematic, we simulate the schematic diagram by click the simulate button. The simulation has finished and there is no error. So this is the tuning parameter for the schematic. For the L1, the value is 709.884 nanohenry. The minimum value we can tune is 354.942 until 1064.826. For the C1, the value is 0.04725 picofarad. The minimum value we can tune is starting at 0.023625 until still the maximum value 0.070875. For the L2, the value is 0.0599 nanohenry. The starting point is at 0.0295 and we can end at the starting point 0.0885. For the C2, the value is 0.5679. The value we can start tuning is at 0.28395 and the maximum value is 0.85185. For the L3 and the L1, the value is the same. For the value of L3 and C3, the value is just the same for the L1 and C1. So this is the result for the passband bandwidth. So this is the stop band and this is the passband. So for the minimum frequency, 862.5 megahertz. So maximum frequency is 874.0 megahertz and the cutoff frequency is 869.0 megahertz. So this is the result for the previous lab 1B. So compared to the get, it is accurate and the value is almost the same. So we assume that the result is pass. So for the Smith chart graph, we only select S21. The frequency is 868.5 mega and the impedance is 10.006 minus 9.657. So the frequency range is in between 850.0 mega to 900 megahertz. To compare with our previous lab 1B, the value is the same. So the Smith chart is using the starting 850 megahertz and our stop band we use is 900 megahertz. This is both result for the Smith chart and the passband filter graph.